My name's Ian. I'm a dad, I'm an engineer, I've done some business, and sometimes you end up sort of feeling down about the hurdle of climate change. For example, ships. The big ships moving across the ocean. It's way too much energy to ever use batteries. Uh, Diesel has 36 times the amount of energy in a volume as a lithium battery. So it's just kind of impossible to do with batteries, but it's 3% of greenhouse gas. See the problem. See why people can feel down. But there's an idea, there's possibly a workable idea. This is it. This is it. It is take nitrogen, the air's 78% nitrogen, combine it with hydrogen you get from green power electrolysis water, and you have a liquid fuel. This is ammonia, and it might work. In fact, lots of people are saying it will work. But is it dangerous? Is this a catastrophe waiting to happen? I'm not a ship designer, but there was some news that came out just last week that I kind of want to share and decode. So this group of companies, uh, NYK Line, J Eng, IHI Power, NSY, ClassNK. Who are these guys? Group of Japanese companies. They released this press release saying they come up with machine room safety for ammonia, MRS, classification notation. Demonstrates a ship equipped with excellent ammonia safety measures for a machine room. What does that mean? Right? Does that mean ammonia is safe? So ClassNK, what they do is they're a body that thinks about the engineering and the registration of ships. So it's the vessel plans, it's tracking them, the registrations, it's looking at all the materials. Is this seaworthy? Um, the equipment and outfitting gear, and the assessment, so reviewing and then registering, so tracking, making sure nobody disconnected something, of ship safety systems, the management, the security systems. Okay. So if you were ever wondering, who decides and who checks lifeboats? How many should we have? People like this. They'll say how many you should have, and they'll keep a record of that so you can come back to it later and say, yeah, they're still here. And they're not small. They're Japanese, but they're 20% of the world's fleet. In this classification, we already ship a lot of ammonia. It's in tanks on ships. So the difference we're talking about is taking that ammonia and using it as a fuel. So it's in a big tank, and we're going to take a line, a fuel line, and connect that to a motor. Now that puts it in different parts of the ship, but smallish amounts, right? A fuel line compared to a massive tank. And they're going to look at this sort of, they have all the history on shipboard safety and what kind of accidents have happened in the past, and in machine room safety. So that could be mechanical danger, so like high pressure. It could be a fire danger or explosive danger, and it could be a toxic danger. Um, Other fuels are actually similarly toxic, uh, if you go into a room with a lot of gasoline fumes, it's going to make you loopy. If you go into one with carbon monoxide, you might not notice until you drop dead. So there's history on all this, and they go through and risk by risk. So whether that's ventilation in a machine room, whether it's the bulkheads, how many doors, and having safe paths out, ventilation, double wall, tanks, all that stuff they go through and they say, okay, this is how we do this safely. Uh, it is we know, say diesel or bunker fuel, uh, ammonia is still different, so it disperses in the air, it has a different density. So they go through and they do like the real science, a CFD simulation looking at the concentration of a cloud if it were to accidentally release. Remember, ammonia, it will not hurt you at a low concentration. So the danger is it's a grade. How much and for how long, right? So if you can vent it, um, etc. It's not binary. It is a pretty complex modeling system to figure out, what's the worst case scenario. This is another example, looking outside the ship. If it had to vent a bunch of stuff, what's the shape of that cloud? And again, concentration. So if you had an ammonia leak and you uh, basically, what am I looking for? Diffuse that with a bunch of air to make it so it isn't a high concentration. It won't hurt anyone, won't hurt any wildlife. So it's all about how can you get an accidental high concentration and how can we mitigate that risk? And again, the reason we're doing this, electrolysis, we know about, making ammonia, we know about, and ammonia, it's 6.5 times the energy in a volume as hydrogen. It's a better fuel. It's low pressure. It has a lot more energy. So on a ship, it's a better fuel. It's much closer to diesel than hydrogen. So at the end of the day, what this news release basically says is ClassNK has looked at all the risks and they said, if you follow these engineering standards that we certify and we stand behind and we're liable for, this is a safe fuel used in an engine. We approve this. And that's great news, right? 100% green fuel that can be used in a place where batteries won't work, where hydrogen won't work. So there you go. ClassNK. Cheers.